Welcome to our video today where we'll be exploring a fascinating topic that combines machine learning, deep learning, and Python programming, predicting the path of wildfire smoke. With the increasing frequency and severity of wildfires, understanding how smoke behaves is crucial for public health, environmental monitoring, and emergency response planning. In this video, we'll delve into the complexities of tackling this challenge using AI and provide a comprehensive guide to help you estimate the project timeline. Predicting wildfire smoke paths involves analyzing various factors such as weather patterns, terrain, fuel types, and more. To develop an accurate prediction model, we would need to integrate multiple disciplines like atmospheric science, geography, and computer science. Our approach will involve machine learning and deep learning techniques, utilizing Python as our primary programming language. Firstly, we'll start by collecting and preprocessing a large dataset of historical wildfire smoke events, including relevant features such as meteorological data, topography, and vegetation information. This step alone can be time-consuming, requiring significant effort to gather, clean, and transform the data into a suitable format for modeling. Next, we'll explore various machine learning algorithms, such as random forests, gradient boosting, or support vector machines, to identify the most relevant features contributing to smoke path prediction. We may also need to employ feature engineering techniques to create new variables that better capture the underlying relationship. Moving on to deep learning, we can utilize convolutional neural networks, CNNs, or recurrent neural networks, RNNs, to learn spatial and temporal patterns in the data. This will enable us to model complex interactions between weather systems, terrain, and smoke behavior. However, training these models requires significant computational resources and expertise in hyperparameter tuning. To further refine our predictions, we might incorporate additional data sources, such as satellite imagery or sensor networks, which would necessitate data fusion techniques and potentially more advanced modeling approaches like ensemble methods or transfer learning. In summary, predicting the path of wildfire smoke using Python, machine learning, and deep learning involves collecting and preprocessing large data sets, exploring multiple machine learning algorithms for feature selection and modeling, employing deep learning techniques to capture complex patterns, incorporating additional data sources through data fusion, refining predictions through ensemble methods or transfer learning. Predicting the path of wildfire smoke is a challenging project that requires interdisciplinary expertise, significant computational resources, and careful consideration of various factors. By breaking down this complex problem into manageable components, we've provided a comprehensive overview to help you estimate the project timeline. If you have any questions or would like to share your experiences with similar projects, please leave a comment below. Don't forget to like this video and subscribe for more informative content on machine learning, deep learning, and Python programming. What's next? Consider exploring other applications of AI in environmental monitoring or emergency response planning. The possibilities are endless.